This demo shows that confidential containers secure a Tekton task run pod. This is essential to protect a software supply chain, even if the cluster administrator is compromised. A Tekton task run pod using confidential containers protects an artifact signing key. Confidential containers achieve the above by using trusted execution environment, a sealed secret unsealed by remote attestation, and task run validation with a measured policy. So why should we secure a Tekton task run pod? Integrity of an artifact signing key is essential for a secure software supply chain. That is, we want to ensure that a signed artifact is built from a signed source repository tag. This integrity relies on three properties. First, the signing key is kept confidential, and second, pipeline steps is designed to ensure a trust chain between signed artifact and the signed tag. And third, the pipeline steps are immutable. So we show confidential containers ensure the first and third property, even if a cluster administrator is compromised. What we show in this demo is that confidential containers protect an artifact signing key and task run steps from a malicious cluster administrator. We have two Tekton pipelines. One is vanilla and the other is secure by confidential containers. The secure pipeline runs in a trusted execution environment and is backed up by a remote trusted service for attestation and secret resource management. The administrator cannot inspect the artifact signing key used by the secure task run pod on the Kubernetes cluster running the secure pipeline. The administrator also cannot modify steps of the secure task run pod. So let's show the demo. We have two pipelines embedded in event listeners. One is vanilla and the other is secure. Both pipelines clone the same repository tag, build the same container image, and deploy the same application. The differences of the secure pipeline from the vanilla pipeline is it uses a custom runtime class, kata remote, to deploy confidential containers, and it uses a sealed secret to represent the artifact signing key, and it annotates an init data to validate confidential containers. The application looks like this. And the vanilla pipeline uses a standard Kubernetes secret to represent the signing key. Therefore, the administrator can inspect the contents of the signing key. In contrast, the secure pipeline uses a sealed secret to represent the signing key. This feature is provided by confidential containers, and it represents a secret value as a resource reference to a remote trusted service. Therefore, the cluster administrator cannot see the contents as a Kubernetes API object. But assuming that the cluster administrator is malicious, the administrator can mutate any Kubernetes API object. For example, the administrator can deploy a mutating webhook to modify a task run pod generated by the Tekton pipelines controller. So here we assume that the attacker will modify the application after the pipeline verifies the tag, but before it builds an artifact. But the vanilla pipeline cannot detect this kind of attack. The build completes and the artifact is signed successfully, but the application can be modified like this. In contrast, the secure pipeline fails when it tries to use the artifact signing key. This is because remote attestation failed, which is required to unseal the sealed signing key. So let's go into detail about what is happening when the secure task run pod detects the attack. This diagram shows what happens when a secure task run pod uses a sealed secret. When a secure task run pod is created with a sealed secret, it triggers remote attestation by a trusted service, Trusty, to get the actual secret value from Trusty. The remote attestation request includes an init data hash measured by the trusted execution environment or of the secure task run pod. This init data includes a policy to validate containers created in the secure task run pod. Trusty unseals the secret only when the secure task run pod sends a valid attestation request having an init data hash which matches with a known reference value. If the attacker modifies a task run step, the policy rejects creation of the container corresponding to the step. And if the attacker modifies both a task run step and the policy, then the remote attestation fails since the modified init data hash does not match with any reference value. Therefore, the artifact signing key is not unsealed if a task run step is modified by the attacker. So in summary, this demo shows that confidential containers secure a text-on task run pod. This is essential to protect a software supply chain, even if the cluster administrator is compromised. A text-on task run pod using confidential containers protects an artifact signing key, and confidential containers achieve the above by using trusted execution environment, a sealed secret unsealed by remote attestation, and task run validation with a measured policy. Thank you very much for watching.